Welcome to the Red Raven UAS podcast.
We're here to take a deep dive into the technology that's really reshaping public safety operations. Specifically, how agencies can move past all the hype and build drone programs that are safe, compliant, and truly built to last.
And that's our mission. At Red Raven UAS, we provide customized drone training, program development, and expert consulting. We work with public safety, government agencies, and enterprise teams to help them, design, build, and optimize their drone programs based on real-world experience.
Today, we're drilling down into what I think is one of the most critical applications for this technology, and that's firefighting. When you integrate unmanned aircraft systems drones into the fire service, they become this ultimate operational asset. We call it a force multiplier.
Okay, I want to focus on that term force multiplier, because if I'm a fire chief or maybe a city administrator looking at budgets, I need to know what that really means. What's the quantifiable value? How does a single drone team multiply the capability of an entire operation?
It's the capability lift without the payroll increase. So look at it this way. Firefighters on the ground, even with the best equipment, are limited by their line of sight. They're limited by smoke, by walls. The second you launch a drone, you give the incident command, the IC, a full real-time map of the entire scene.
So the return on investment isn't just about seeing the fire from above, it's about better, safer intelligence.
Precisely. We've seen it time and again. The data from a drone allows an IC to spot a critical risk, like a roof that's about to collapse, and that saves an entire team. That kind of rapid, informed decision-making, well, it saves lives, it saves property, and it reduces risk for the crews. That's the measurable return.
Let's unpack that a little. Where is that aerial view most critical? Let's start with a structural fire, where everything is happening so fast.
Right. For structural fires, the drone's number one job is immediate overwatch. When engines arrive, the IC often only has smoke color and volume to go on. But a drone orbiting above delivers this live overhead view directly to their command post.
And what are they looking for in that feed? What are the key data points they need?
They're looking for structural diagnostics. The biggest danger for firefighters is when they go into a building or get up on the roof. The aerial view, especially with a thermal camera, can spot really subtle signs of heat loading on the building. They can pinpoint where the fire is, see if a firewall is holding, or, and this is critical spot, things like a sagging roof line. That means a collapse is imminent.
So they can shift from an offensive to a defensive attack almost instantly.
Exactly. They can pull crews back before a catastrophic failure happens. That real-time safety check just fundamentally changes the risk for every single person on scene.
Okay, so that's for structure. But when we talk about wildfires, the challenge is completely different. It's about scale, not just a single building.
The challenge changes from minutes to miles, you're right. The sheer scale of a wildfire demands constant reconnaissance. A single drone can track the fire's progression over vast, often really rugged terrain, and it's much faster and safer than sending scouts out on the ground.
And for an incident commander who's trying to manage a fire line that could be miles long, what's the most valuable piece of information they get from that?
Accuracy. It's all about accuracy and containment. The drone feed tracks the fire's perimeter and can identify where it's spotting out ahead of the main front. This is crucial for planning fire breaks and for guiding those really expensive manned aircraft for their drops.
You don't want to miss with a load of fire retardant.
You absolutely don't. A drop can cost thousands of dollars. The drone gives them the precise GPS coordinates to make sure that retardant lands exactly where it needs to, preventing the fire from jumping a critical road or a river.
That makes sense. And speaking of difficult terrain, let's pivot to search and rescue SAR. These missions are almost always in places where ground crews are slowed down.
SAR missions are all about time. And drones are just game changers here because they can search huge, complex areas. Think dense forests, canyons, flood zones, so much faster than people on foot or even a low-flying helicopter.
But what about visibility, especially if there's smoke from a fire or the search goes into the night? How do they see?
And that's where the sensors become, though they become non-negotiable. This leads us right into the power of thermal imaging, which is critical for SAR, but also for all these high-risk scenarios.
They see heat, but how does that translate into useful information?
The difference is just profound. I mean, a regular camera is completely useless in heavy smoke or total darkness. But a thermal camera reads temperature differences. It gives you a live heat map of the scene. And for fire ops, this does two vital things that nothing else can.
Okay, let's start with after the fire is out, the mop-up phase.
Right. The mop-up phase is deceptively dangerous. The visible flames are gone, but the biggest threat is reignition from these hidden hotspots buried deep in the debris or inside a wall. If you miss those, the fire can just restart hours or even days later.
And that's a huge risk.
It is. A thermal camera flown over the scene instantly highlights every single one of those temperature anomalies. So crews can go directly to the source of the heat, extinguish it for good, and know the scene is safe. It prevents devastating secondary losses.
So it's basically an insurance policy against reignition. What's the second key function? You mentioned finding people.
Exactly. Finding human body heat in low visibility. The human body gives off a heat signature. In a building that's filled with smoke from floor to ceiling, where a firefighter can't see their own hand, a drone with a thermal camera can look down through that smoke and detect the heat from a victim. It can cut search times from hours down to minutes.
Wow.
And in those situations, minutes are everything. It directly saves lives.
Which brings us back to safety and hazmat scenarios. By definition, you're dealing with unknown, possibly deadly threats. You can't just send someone in to read a label on a truck.
And you shouldn't have to. Hazmat is all about managing risk and exposure. Drones let that initial assessment happen from a safe distance. They can fly close enough to read those little hazardous material placards so you know exactly what chemical you're dealing with.
And they can track the plume.
They can track the chemical plume, assess its trajectory, its drift, all without exposing a single person to dangerous fumes. That initial data forms the foundation for the entire response strategy.
The operational case is overwhelming. But we have to talk about the financial side. I know these programs can stall because they're seen as expensive, specialized toys even. How do you justify this to a city council with a tight budget?
You know, the cost comparison is actually one of the strongest arguments you can make. When you put a drone program up against traditional aerial support, there's just no contest.
You mean like a helicopter?
Exactly. The cost to buy one is massive. And the operational costs, fuel, maintenance, specialized pilots, they are continuous and, frankly, astronomical. Drones are battery-powered. Their operational fuel cost is basically zero, and maintenance is far simpler.
So the barrier to entry is much lower.
When you weigh that low cost against a multi-million-dollar building burning down or the immeasurable cost of a firefighter's life, the drone becomes a necessary safety investment. It's not a toy.
That makes perfect sense. But agencies aren't all the same. A huge city department needs something different from a small suburban volunteer fire district, right? There's no one-size-fits-all program.
That's a crucial point. And that's where the planning and the consulting really become key. You have to scale the program to your specific needs and budget. We generally see three common models taking shape.
Okay, walk me through them. What's the starting point?
The simplest entry is what we call a small-scale engine-based program. This is for immediate opportunistic use. You have a couple of small, reliable drones stored right on the fire engine. The first crew member on scene, who is a certified pilot, can get it in the air in a minute or two just to get that initial overhead view.
So it's quick, simple, and ready to go. What's the next level up from that?
That would be a mid-scale dedicated program. This is for an agency that's really formalized the process. They've invested in more advanced drones with, say, high-res thermal and zoom cameras. And crucially, they have a dedicated pilot team and often a mobile command vehicle. It makes sure that high-quality live data feed goes to the IC and to other commanders and to support units all at the same time. It allows for much more complex operations.
And then the third model, which feels like the future of this technology, drone as first responder, or DFR.
The advanced DFR model. This really shifts the whole response dynamic. Instead of waiting for engines to show up, the drones are launched automatically, right when a 911 call is dispatched.
So the drone actually gets to the scene before the fire engine.
That's the idea. It gets there first and provides that critical high-speed initial intel to the crews while they're still driving. They can confirm if it's a real structure fire or just a trash can. They can see access points, spot potential victims. That advance warning is invaluable. It lets them plan their attack before they even arrive.
It sounds like the complexity just goes up exponentially with the DFR model. I mean, going from a simple drone on a truck to an automated response system, that must require some serious planning and FAA coordination.
That is the biggest hurdle. It's one thing to buy the hardware. It's another thing entirely to launch a program that's effective, scalable, and fully compliant with all the rules. You're dealing with FAA Part 107, certificates of authorization or COAs, developing SOPs. It's a lot.
And that's where expertise in this area becomes absolutely necessary. So how does a company like Red Raven help an agency bridge that gap between just owning a drone and having a truly effective program?
We provide the roadmap. First is the UAS consulting and program planning. We offer vendor-neutral advice to design a program that fits their exact scale, whether it's a small startup or a full DFR launch. We help with the SOPs, the regulatory paperwork, and make sure they buy the right hardware for their mission. And once the plan is built, it's all about the pilot's proficiency. That's our on-site team training. We do scenario training that reflects the real-world pressure of a fireground. We don't just teach them to fly. We teach them to interpret thermal data and operate safely under complex FAA rules.
And underpinning all of that is the legal requirement, the certification.
Correct. Every pilot has to be legally certified. Our Part 107 online course is designed to make sure their staff passes that FAA exam on the first try. We make sure the entire team is proficient, compliant, and ready to fly legally.
It sounds like the big takeaway is that drones are essential, but their effectiveness really depends on that foundation of compliance and high-level training.
That's it, exactly. Capability is useless without compliance and proficiency.
This has been a really clear look at why this technology is so fundamentally changing public safety. Before we go, here's a thought for you to consider based on our deep dive today. If DFR models can give us critical intelligence 5 minutes before engines arrive, what other strategic, non-firefighting uses, like rerouting traffic in real time or even notifying potential victims to evacuate, might become standard procedure in that precious 5-minute gap? Thanks for listening to the Red Raven UAS podcast. Visit redravenuas.com for consulting, training, and FAA Part 107 certification, and check out the current special pricing on our Part 107 course.